Thunder rolled across Europe long before anyone saw the aircraft that caused it. Built heavy, armed heavier, and sent into skies crowded with danger, one American fighter forced pilots and commanders to rethink what air combat really meant. It was not the fastest turner, nor the lightest machine in the fight, yet it carried a level of firepower that changed how battles were fought, from high-altitude escorts to brutal, low-level attacks. Behind every burst of gunfire were hard decisions about fuel, risk, survival, and strategy. This is not a story of easy victories. It is the story of a machine pushed into roles no one fully expected, where every mission tested the limits of engineering, tactics, and the pilots who flew straight into flak-filled skies. A fighter built around firepower. Why 8.50 cals defined the P-47's design limits. The Republic P-47. Thunderbolt did not begin as a lightweight dogfighter. From its earliest design phase, Republic Aviation pursued a heavily armed, high-altitude interceptor capable of delivering sustained firepower while surviving intense combat environments over Europe. Central to that concept were 8 Browning M2.50 caliber machine guns mounted in the wings. This configuration shaped nearly every engineering decision that followed. Firepower was not an addition to the aircraft. It was the foundation around which the entire machine was built. Each of the 8.50 caliber guns added weight, recoil forces, and structural demands that influenced the wing's size and strength. The Thunderbolt required thick, reinforced wings capable of absorbing vibration and maintaining accuracy during prolonged bursts. Ammunition alone represented a significant load. Standard combat configuration often carried over 3,000 rounds, turning the aircraft into a flying weapons platform rather than a nimble interceptor. Engineers prioritized stability during firing runs over aerodynamic elegance, resulting in a large airframe that contrasted sharply with lighter fighters such as the German Bf-109 or the British Spitfire. The decision to concentrate on heavy armament reflected evolving combat expectations in the early years of World War II. American planners anticipated encounters with heavily armored bombers and durable ground targets. The .50 caliber Browning offered a balance between rate of fire, penetration, and reliability. Compared to cannon armament used by German fighters, the machine guns delivered sustained streams of rounds that increased hit probability during high-speed passes. However, integrating 8 weapons created design compromises. Weight increased dramatically, which in turn required a more powerful engine and a larger fuselage to maintain performance at altitude. To compensate for mass, engineers paired the Thunderbolt with the Pratt & Whitney R2800 double WASP radial engine and a complex turbo supercharger system. This configuration allowed excellent performance at high altitude, where the aircraft could exploit speed in dives and maintain power where many opponents struggled. Yet, the same design decisions created challenges at lower altitudes and in tight-turning combat. The heavy airframe responded more slowly to control inputs, and early pilots often criticized the aircraft for feeling sluggish during dogfights. The 8-gun armament contributed directly to this perception by increasing wing loading and inertia. Recoil management presented another engineering problem. Firing 8 machine guns simultaneously generated substantial vibration and aerodynamic disturbance. Republic addressed this through wing reinforcement and careful gun harmonization. Guns were angled slightly so their streams converged at a chosen distance, maximizing destructive effect during strafing or interception passes. This setup favored high-speed attack runs rather than prolonged maneuvering engagements. The aircraft excelled when diving toward targets, unleashing concentrated firepower, and using momentum to escape. In close turning battles, its strengths were less apparent. The heavy armament also affected fuel consumption and operational range. Carrying large quantities of ammunition reduced available payload for additional fuel in early configurations. Escort missions over Europe exposed this limitation, as the P-47 initially struggled to accompany bombers deep into German territory. Engineers and commanders faced a trade-off between maintaining maximum firepower and extending mission endurance. External drop tanks were eventually introduced, but the need for additional fuel highlighted how the aircraft's weapons load shaped strategic limitations. Continuous firing could deplete ammunition, requiring attention to ammunition conservation, firing discipline, and attack angle. Continuous firing could deplete ammunition rapidly, forcing pilots to make decisions about when to engage and when to disengage. Gun heating and synchronization also demanded technical oversight from ground crews, adding to maintenance complexity. While the weapons were reliable, their integration into a single platform created logistical demands that smaller fighters avoided. Despite these constraints, the 8.50 caliber guns defined the Thunderbolt's battlefield identity. The aircraft could deliver massive bursts capable of destroying locomotives, armored vehicles, and enemy aircraft with sustained fire. This capability later influenced its transition into a dominant ground attack platform. The same mass that limited turning performance provided durability, allowing the aircraft to absorb damage and return to base even after heavy combat exposure. Firepower and survivability became intertwined, reinforcing the original design philosophy even as tactical roles evolved. Engineering debates emerged within Allied circles regarding whether such heavy armament justified the resulting size and weight. Some pilots favored lighter, more maneuverable fighters, arguing that agility mattered more than raw firepower in air-to-air combat. Others valued the Thunderbolt's ability to deliver concentrated damage in a single pass. These disagreements reflected broader strategic questions about how fighters should operate in a war increasingly defined by industrial scale and heavily defended targets. Ultimately, the 8.50 caliber machine guns were not simply weapons attached to an aircraft. They were the structural and tactical core around which the P-47 Thunderbolt was engineered. Every design decision, from wing thickness to engine choice, reflected the demands imposed by sustained firepower. The result was a machine that excelled in specific combat scenarios while accepting clear performance trade-offs elsewhere. The Thunderbolt demonstrated that engineering a fighter around weapons rather than agility created both opportunity and limitation, shaping how it would be used across European battlefields. Too heavy for dogfights? Early combat problems over Europe. When the Republic P-47 Thunderbolt first entered combat over Europe in 1943, expectations did not always match operational reality. Designed as a high-altitude interceptor, the aircraft arrived in a theater dominated by experienced German pilots flying agile fighters such as the Bf-109 and Fw-190. Early encounters exposed a fundamental tension within the Thunderbolt's design. Its size, weight, and firepower made it durable and fast in dives, but those same characteristics complicated traditional turning engagements. Pilots transitioning from lighter aircraft immediately noticed the difference in handling. The Thunderbolt was one of the heaviest single-engine fighters of the war. Fully loaded with ammunition and fuel, it felt more like a high-speed platform than a nimble dogfighter. Initial combat reports described a slower roll response at certain speeds and wider turning radii compared to German fighters. In close-range engagements, this could place American pilots at a disadvantage if they attempted to fight on the enemy's terms. The aircraft's turbo supercharger system added another layer of complexity. While it delivered exceptional performance at high altitude, it required careful engine management. Early operational units faced mechanical teething issues, including reliability concerns tied to the turbo system and the need for extensive maintenance between sorties. Ground crews had to adapt quickly, and pilots needed time to understand how to exploit the aircraft's strengths without overstressing the engine. Range limitations also influenced early combat outcomes. Before the widespread use of external drop tanks, the Thunderbolt struggled to escort bombers deep into German territory. This forced fighter groups to turn back earlier than desired, leaving bomber formations exposed during critical phases of missions. The problem was not a failure of speed or firepower, but a consequence of fuel consumption tied to the aircraft's mass and engine power. Strategic planners began reassessing how to deploy the P-47 effectively within these constraints. Combat tactics evolved through trial and error. Some pilots initially attempted to engage German fighters in tight turning battles, which played to the strengths of lighter enemy aircraft. Losses and near misses quickly changed that approach. Experienced Thunderbolt pilots began emphasizing energy fighting tactics. Instead of turning with opponents, they used altitude advantage, diving speed, and high momentum passes to attack and disengage. The aircraft could exceed speeds that many adversaries struggled to match in a dive, allowing pilots to break contact when necessary. Survivability became a defining factor during these early missions. The Thunderbolt's large radial engine and robust construction allowed it to absorb significant damage. Reports from the 8th Air Force documented aircraft returning with heavy battle scars, including flak damage and bullet holes that might have destroyed lighter fighters. This durability offset some of the disadvantages pilots felt during dogfights. Even when surprised or outmaneuvered, many crews trusted the aircraft's ability to bring them home. Weather and operational conditions over Europe introduced additional challenges. High-altitude escort missions often involved long periods of formation flying in cold, turbulent air. The Thunderbolt's size made it stable, but managing fuel efficiency and maintaining formation demanded discipline. Pilots had to balance aggression with conservation, knowing that extended combat could threaten their ability to return safely. German pilots quickly learned to exploit perceived weaknesses. Luftwaffe tactics sometimes focused on forcing Thunderbolts into low-speed maneuvering fights where their weight worked against them. Intelligence reports noted that enemy fighters attempted to lure P-47 formations into climbing turns or prolonged engagements that drained energy. In response, American units refined their doctrine, emphasizing teamwork and mutual support rather than individual pursuit. Training adjustments followed operational experience. Fighter groups began emphasizing dive and zoom tactics during preparation, teaching pilots to leverage the aircraft's strengths rather than imitate the tactics of lighter fighters. As confidence grew, pilots realized that the Thunderbolt was not poorly suited to combat, but differently suited. Its success depended on altitude control, speed management, and disciplined firing passes rather than close-range turning duels. The early combat period over Europe, therefore, became a phase of adaptation rather than failure. The question of whether the aircraft was too heavy for dogfights gradually gave way to a more nuanced understanding. The Thunderbolt struggled when forced into traditional turning battles, but it excelled when flown as a high-energy platform, capable of delivering powerful attacks and escaping at speed. Lessons learned during these initial months reshaped how Allied commanders deployed the aircraft, laying the groundwork for its later effectiveness in both air-to-air combat and ground attack missions. Fuel, altitude, and range. Operational constraints that shaped its missions. Operational use of the Republic, P-47, Thunderbolt over Europe, was defined as much by logistics as by combat performance. While the aircraft possessed exceptional speed in dives and strong high-altitude capability, its fuel consumption and range limitations imposed clear boundaries on how it could be used during the early stages of the air war. These constraints influenced mission planning, escort coverage, and even the tactical behavior of pilots once combat began. The Thunderbolt's powerful Pratt & Whitney R2800 engine and turbo supercharger system allowed it to perform effectively at high altitude, which aligned with American bomber doctrine. Heavy bombers, such as the B-17 and B-24, operated at altitudes where thinner air reduced some defensive threats, and the P-47 was built to escort them in that environment. However, maintaining power through the turbocharged system required significant fuel. Early missions revealed that endurance was more limited than planners initially expected, especially when pilots had to climb, maneuver aggressively, or respond to enemy interceptors. Before long, range drop tanks became standard equipment. P-47 units based in England often faced strict geographic limits. Fighter groups could escort bombers across the English Channel and into parts of occupied Europe, but deep penetrations into central Germany were beyond their reach. This created a vulnerable gap, where bombers continued without fighter protection, increasing losses during heavily defended raids. Commanders had to decide whether to prioritize escort distance or retain enough fuel for combat maneuvering and safe return. Altitude further complicated fuel planning. Flying at higher altitudes improved engine efficiency in certain regimes, and allowed the Thunderbolt to exploit its turbocharged performance. Yet, climbing to those heights consumed fuel rapidly. Pilots frequently balanced throttle settings and formation speeds to conserve fuel during the outbound leg of missions. Any deviation, such as chasing enemy fighters too far from formation, risked leaving the aircraft short of fuel on the return flight. Weather conditions over northern Europe added unpredictability. Strong headwinds during outbound routes could significantly increase fuel consumption, forcing formations to turn back earlier than scheduled. Mission planners studied forecasts closely, but atmospheric conditions could change mid-flight. Reports from the 8th Air Force describe pilots constantly recalculating fuel margins while maintaining formation discipline and preparing for combat at any moment. The introduction of external drop tanks marked a turning point. These tanks extended the Thunderbolt's operational radius and allowed escort missions to reach deeper into German airspace. However, drop tanks introduced new tactical considerations. Carrying external fuel reduced maneuverability and increased drag until the tanks were released. Pilots had to choose the right moment to jettison them, balancing the need for agility against the risk of running low on fuel later in the mission. Enemy fighters sometimes attempted to engage Thunderbolts before they dropped their tanks, hoping to exploit this temporary disadvantage. Operational constraints also influenced how the aircraft was used once it reached target areas. Pilots could not remain indefinitely over contested zones. Fuel reserves dictated limited engagement windows, encouraging high-speed attack passes rather than prolonged aerial combat. The aircraft's design favored these brief, powerful encounters, but the time pressure added stress to decision-making. A missed attack run might not allow for a second attempt if fuel levels dropped too low. Ground crews and maintenance teams played a critical role in managing these limitations. Precise fuel calculations were conducted before each sortie, taking into account altitude, expected combat duration, and contingency routes. Even small errors could have serious consequences. Emergency landings due to fuel shortages were not uncommon during early operations, highlighting how closely performance was tied to logistical planning. Strategically, the range problem influenced broader Allied decisions. Until longer-range fighters such as the P-51 Mustang became widely available, the Thunderbolt carried much of the burden of escort duty within its operational envelope. Commanders had to coordinate overlapping fighter coverage zones, ensuring bombers received protection where possible. These constraints shaped the tempo of operations and the timing of major bombing campaigns. Fuel, altitude, and range therefore defined more than technical specifications. They determined where the Thunderbolt could fight, how long it could remain in combat, and what tactics pilots employed once engaged. The aircraft's strengths at high altitude and in high-speed flight were undeniable, but they existed within strict logistical boundaries. Understanding those limits allowed Allied forces to deploy the Thunderbolt more effectively, transforming operational challenges into structured doctrine that guided missions across the European theater. When escort failed, the shift toward low-altitude strafing warfare. As combat operations over Europe intensified, the role of the Republic P-47 Thunderbolt began to change. Early expectations positioned the aircraft primarily as a high-altitude escort fighter, protecting American bombers during long missions over occupied territory and Germany itself. However, limitations in range, evolving air superiority conditions, and the realities of battlefield demand gradually pushed the Thunderbolt into a different and far more aggressive mission profile. Low-altitude strafing and ground attack operations became a defining aspect of how the aircraft was used. The transition did not happen suddenly. During 1943, escort missions exposed gaps in fighter coverage, particularly before long-range escorts could accompany bombers all the way to distant targets. When bomber formations moved beyond effective escort range, German fighters often concentrated attacks. Losses during these periods forced Allied planners to reconsider how fighters could contribute beyond traditional interception. As the Luftwaffe's ability to challenge Allied air power began to decline in certain regions, fighter units were reassigned to exploit this advantage by targeting infrastructure on the ground. The Thunderbolt's design made it unexpectedly suited for this new role. Its large radial engine, reinforced airframe, and heavy armament allowed it to absorb significant damage from ground fire. 8.50 caliber machine guns delivered dense streams of fire capable of destroying trucks, locomotives, anti-aircraft positions, and lightly armored vehicles. Pilots quickly learned that the aircraft could dive at high speed toward targets, unleash concentrated bursts, and escape before defensive guns could respond effectively. These characteristics turned a former escort fighter into a powerful low-altitude strike platform. Operational doctrine began to evolve alongside these missions. Instead of remaining tightly bound to bomber formations, some P-47 groups received orders to conduct fighter sweeps ahead of or after bombing raids. These sweeps targeted rail lines, airfields, and troop concentrations. The goal was disruption rather than precision. Strafing runs aimed to damage transport networks and slow German logistics, forcing the enemy to divert resources toward defense and repair. Missions became more frequent as Allied ground offensives prepared for large-scale operations across Western Europe. Low-altitude warfare introduced new risks that differed from high-altitude escort duty. German anti-aircraft fire, commonly referred to as flak, became the primary threat. Even small-caliber weapons positioned along roads and railways could damage control surfaces, engines, or fuel systems. Pilots flying at treetop height faced limited reaction time, making every attack run a calculated gamble. Reports from fighter groups described aircraft returning with heavy damage from ground fire, underscoring how dangerous these missions were despite the Thunderbolt's durability. Tactics adapted to minimize exposure. Pilots often attacked in pairs or small formations, diving toward targets at steep angles to increase speed and reduce time spent within defensive fire zones. After firing, they would pull up sharply and reposition for another pass only if conditions allowed. Communication between pilots became essential, with wingmen providing cover against unexpected enemy fighters or tracking ground threats that might not be visible during a high-speed dive. The psychological aspect of strafing missions also differed from air-to-air combat. Escort duty involved long periods of formation flying punctuated by brief encounters with enemy aircraft. Ground attack required constant alertness at low altitude, where terrain, weather, and obstacles posed additional hazards. Pilots navigated through smoke, debris, and rapidly changing battlefield conditions while managing ammunition and fuel levels. Decision-making shifted from strategic escort positioning to immediate survival and target assessment. By 1944, the Thunderbolt's role in close air support and interdiction had expanded significantly. As Allied forces prepared for and executed operations such as the Normandy landings, P-47 units attacked supply convoys, bridges, and defensive positions ahead of advancing troops. The aircraft's ability to carry bombs and rockets alongside its machine guns increased its versatility, allowing it to strike a wider range of targets. What began as a response to escort limitations became a core component of Allied tactical air power. The shift toward low-altitude strafing warfare reflected broader changes in the air war over Europe. As Allied air superiority grew, fighters were freed from strictly defensive escort roles and reassigned to offensive missions that weakened German infrastructure. The Thunderbolt's heavy construction and concentrated firepower proved valuable in this environment, even though the aircraft had not been originally designed solely for ground attack. When escort failed to meet every operational need, adaptation filled the gap. The Thunderbolt transformed from a high-altitude guardian of bombers into a relentless attacker at low altitude, using speed, durability, and sustained firepower to reshape the battlefield below. This evolution demonstrated how operational pressures could redefine an aircraft's purpose, turning design compromises into tactical strengths under changing conditions of war. Flak zones and German countermeasures, the rising cost of ground attack. As the Republic P-47, Thunderbolt became increasingly involved in low-altitude missions across occupied Europe and Germany. The dangers facing its pilots shifted dramatically. Ground attack operations exposed the aircraft to threats that differed from traditional air-to-air combat. Instead of engaging enemy fighters at altitude, Thunderbolt pilots now flew directly into heavily defended areas filled with anti-aircraft weapons, hidden defensive positions, and evolving German countermeasures designed specifically to stop strafing attacks. Flak, the German term for anti-aircraft fire, became the most persistent danger. Aircraft weapons, hidden defensive positions, and evolving German countermeasures designed specifically to stop strafing attacks. Flak, the German term for anti-aircraft fire, became the most persistent danger. While heavy flak batteries threatened high-altitude bombers, the Thunderbolt's strafing role placed it within range of lighter automatic weapons that were more difficult to detect. Small-caliber cannons and machine guns were positioned along rail lines, roads, bridges, and supply depots. These weapons created dense defensive zones that pilots had to cross repeatedly during attack runs. Even minor hits could damage control cables, puncture fuel tanks, or shatter canopy glass. German forces adapted quickly to the growing threat posed by fighter bombers. As Allied aircraft began targeting transportation networks, defenders dispersed anti-aircraft guns rather than concentrating them only around major cities. Mobile flak units followed convoys or protected railway yards, forcing pilots to assume that nearly every potential target was defended. Camouflage also improved. Vehicles were hidden beneath trees or moved at night to reduce vulnerability, making identification from the air more difficult and increasing the chance of wasted ammunition or accidental attacks on non-military targets. The risk level rose as mission frequency increased in 1944 and 1945. Thunderbolt units were often tasked with multiple sorties per day during periods of intense Allied offensives. Fatigue affected both pilots and ground crews, and the pressure to maintain constant attacks on German logistics left little time for rest. Survival depended not only on the aircraft's rugged construction, but also on disciplined attack techniques. Pilots adjusted their methods to reduce exposure. Instead of flying directly toward a target at low speed, many adopted high-speed dive approaches that shortened the time spent within defensive fire. Attacks were frequently staggered so that one aircraft engaged, while others observed the ground for muzzle flashes or tracer fire. Even with these precautions, losses mounted. The Thunderbolt's durability allowed many damaged aircraft to return to base, but maintenance crews faced increasing workloads repairing flak damage to wings, engines, and control surfaces. German fighter units also contributed to the danger when opportunities arose. Although Allied air superiority limited large-scale interceptions, isolated Thunderbolts operating at low altitude were vulnerable to sudden attacks. German pilots sometimes waited near known attack routes, attempting to catch fighter bombers as they pulled out of dives or climbed away from targets. These encounters reinforced the need for mutual support within formations, as a single aircraft flying alone faced heightened risk from both ground and air threats. Another challenge emerged from the complexity of identifying targets in crowded battle zones. As Allied armies advanced, the front lines shifted rapidly. Thunderbolt pilots had to distinguish between friendly and enemy forces while flying at high speed under fire. Mistakes carried serious consequences. Commanders introduced stricter briefing procedures and improved communication with ground units to reduce friendly fire incidents. But the pace of operations made perfect coordination difficult. Mechanical stress increased alongside combat intensity. Repeated high-speed dives, followed by rapid pullouts, placed strain on the aircraft's structure. Combined with damage from flak, these stresses required careful inspection after each mission. Ground crews became essential partners in sustaining operations, replacing damaged panels, repairing hydraulic systems, and ensuring that the aircraft remained safe to fly despite the harsh conditions of low-altitude warfare. The growing danger of flak zones forced Allied planners to weigh the benefits of ground attack against its rising cost. Strafing missions disrupted German supply lines and weakened resistance, but they also exposed pilots to continuous risk. Some commanders debated whether fighter bombers were being used too aggressively in heavily defended areas. Others argued that the pressure applied by these attacks shortened the war by crippling enemy mobility. The discussion reflected a broader strategic question about how much risk was acceptable to achieve operational goals. Ground attack warfare therefore carried a price that extended beyond individual missions. Every destroyed train or convoy represented a tactical success, yet each sortie passed through an invisible network of defensive guns waiting for an opportunity. The Thunderbolt's heavy construction allowed it to survive many encounters that would have destroyed lighter aircraft, but durability did not eliminate danger. As flak zones expanded and German countermeasures intensified, the aircraft's role became both more effective and more hazardous, highlighting the constant balance between offensive power and survival on the European battlefield. Highlighting the constant balance between offensive power and survival on the European battlefield. Mechanical stress, pilot risk, and tactical debate inside Allied command. By the later stages of the European air war, the Republic P-47 Thunderbolt had proven itself as a powerful fighter bomber. Yet its growing role in constant ground attack operations raised serious questions within Allied leadership. The aircraft's durability allowed it to survive punishment that destroyed many lighter fighters, but sustained use under extreme conditions introduced mechanical strain, increasing pilot risk, and fueling debate among commanders about how aggressively the Thunderbolt should be deployed. Mechanical stress became a central concern as missions intensified during 1944 and early 1945. Low-altitude strafing runs required steep dives followed by rapid pullouts that placed heavy loads on the wings and airframe. Unlike high-altitude escort missions, these maneuvers were repeated multiple times during a single sortie. Over time, stress fractures, control surface wear, and hydraulic issues appeared more frequently. Maintenance crews conducted extensive inspections after missions, often discovering hidden damage caused by vibration or near misses from anti-aircraft fire. The Thunderbolt's radial engine was known for reliability, but operating at low altitude introduced new challenges. Dust, debris, and fragments from exploding targets could enter the engine intake during attack runs. High power settings used to escape flak zones increased heat and fuel consumption, placing additional strain on internal components. Engineers and mechanics worked continuously to keep aircraft operational, balancing the need for rapid sortie generation with safety requirements that demanded careful examination between flights. Pilot risk grew alongside mechanical strain. Flying close to the ground meant less time to react to failures. A damaged control cable or fuel leak that might be manageable at altitude could become fatal at treetop height. Thunderbolt pilots faced a combination of threats that rarely existed during earlier escort roles. They navigated through dense anti-aircraft fire, changing weather, and the physical stress of repeated high-speed maneuvers. Even experienced pilots described ground attack missions as among the most dangerous assignments of the war. These realities sparked tactical debates inside Allied command structures. Some officers argued that the Thunderbolt's rugged construction justified its continued use in aggressive low-altitude operations. They pointed to successful interdiction campaigns that disrupted German transportation networks, slowed reinforcements, and supported advancing ground forces. According to this view, the aircraft's strength lay in its ability to absorb damage while delivering sustained firepower, making it uniquely suited to close air support. Others questioned whether the cost in aircraft and pilot fatigue was becoming too high. Reports from certain units noted rising maintenance hours per flight and increasing attrition from flak damage. Commanders debated whether fighter bombers should limit the number of attack passes per sortie or avoid heavily defended targets altogether. The discussion reflected broader concerns about preserving experienced pilots while maintaining pressure on German infrastructure during critical phases of the war. Operational planning evolved as a result of these debates. Some units adopted stricter rules for engagement, emphasizing coordinated attacks rather than repeated individual strafing runs. Pilots were encouraged to strike quickly and disengage rather than circle back into defended areas. Briefings placed greater emphasis on reconnaissance reports identifying flak concentrations, allowing formations to adjust approach angles and reduce exposure. These changes did not eliminate risk, but they represented attempts to balance effectiveness with survivability. Another dimension of the debate involved the psychological impact on pilots. Continuous ground attack missions demanded intense concentration and exposed crews to constant danger from unseen threats below. Fatigue affected reaction times and decision-making, increasing the likelihood of mistakes. Commanders monitored sortie schedules and attempted to rotate pilots when possible, though operational demands often limited opportunities for rest. The debate ultimately reflected a larger truth about wartime aviation. Success was not defined solely by performance statistics or battlefield victories. It depended on maintaining a balance between capability and sustainability. The Thunderbolt's role demonstrated that even a powerful aircraft required careful management to remain effective. Mechanical stress, pilot risk, and tactical uncertainty shaped decisions at every level, reminding Allied planners that technological strength could not replace the need for disciplined strategy and constant adaptation.